Ladies and gentlemen, please join us at the stage for our next speaker. Martyn Hill is going to be talking to us about all things Spectrum networking related. Martyn, over to you, sir.
Thank you, Chris. Wow, this is loud. Slight change of tack from the previous talks you may have been listening to. Maybe a little bit more technical. Those I spoke to a little bit earlier, this is the talk you wanted to come and hear about networking. Networking obviously is a pretty broad topic, but how it relates to retro computers is something I don't think has really been explored much before. In particular, the Sinclair network is what I'm going to be focusing on. That includes the Sinclair Spectrum and the Sinclair QL, and indeed the Sinclair ZX, the ZX Spectrum Next with a QL core, all are able to actually network together. So, which machines does this sort of networking actually support today? Well, as it says here, the Spectrum itself, which includes with the Interface 1 attachment. The Sinclair QL had the networking capability built in. Most of the other the Sinclair QL clones, like the Q68 and others, also have the networking capability. The CST Thor, which again is another QL clone, also has this by default. And as of about last November, once we finished the driver development and a little bit of hardware, which I'll talk about later, also the Spectrum Next, which also has the ability to connect to the Sinclair network. Why should you care? What can you do with it? Well, there's one of the things you'll notice as you look around the room today, maybe if you've got a number of retro machines at home, is for each new machine, to load the games, to load the software that you want to use, you end up buying pretty expensive SD card readers or hard drives or other things, and on each one you have to then duplicate and transfer all of the software you want to use. Of course, networking we use traditionally on our PCs. We're very used to it on our consoles at home, and with that, all the usual things that we expect from a network are actually available on these retro machines. And as we'll hear about a little bit later, needn't just be the Sinclair computers. So, bootstrapping, the ability to take files and start up your machine from scratch without having all the files loaded locally. Saving your work without having to rely on floppy disks or local SD cards if you've got that, or in the case of the Sinclair machines, the old micro drives, which really are quite unreliable these days. Also, the ability to print files over the network. So again, something we're very used to in our office and our home, but this is also possible perfectly with the network on these retro machines. And a particular aspect that I'm quite keen on seeing developed more is network gaming on these retro machines. We have seen that, and certainly on the 16-bit consoles and later, but with rather cumbersome cable arrangements, parallel port connections, serial connections, or expensive Ethernet cards added to those older machines. So the ability to actually then develop games and be able to play them in a situation like this, if you could imagine, I'm hoping when you come back next year, many of the machines you see here may actually be connected together, downloading the games from a file server, just as we're used to seeing on a normal office network. It also opens up the possibility of cross-platform computing and even multi-computer computing, multi-node computing. All of these things begin to become available once you can actually find a way to connect all your machines in together. Finally, another area that's quite interesting here is the ability to develop electronics projects that use the network as a means to attach all of your different electronic devices. So again, there's quite a lot of scope within using a simple network. But of course, for it to be practical, it needs to be pretty cheap, it needs to be simple, it needs to be reliable, and it needs to be fairly fast. Now, fast, of course, in our retro computer terms, is not like the 1 gigabit connections we're used to on our Ethernet at home. Where the file sizes are much smaller, we can get away with maybe 100 kilobits or 500 kilobits. Some of the retro networks that were popular in the day, such as the BBC EcoNet and others of that era, those ran up to anything from 250 kilobits per second, if that means anything to you, up to about just under 1 megabit per second. So speed of the network is obviously an issue there. Let's move on. In terms of the Sinclair network, and one of the reasons why I've spent the last few years developing it, a few reasons for that. One is it's super cheap. As we'll see in a moment, connecting it really involves simple mono audio cables with the 3.5mm jack plugs on the end. Very simple. You can buy them off the shelf of any length you like. Also, it uses a simple bus topology. You don't need any routers or hubs, so you simply link one computer to the next. You can see in the two diagrams on the screen at the moment. So it's cheap, it's simple, with commonly available components, as long as you actually have the network sockets and the software on the retro machine that we're talking about. This is a talk about Sinclair networking, because that's one that is fairly well established, but to my mind was never really fully developed or evolved. There was a lot more that could have been done with it, but never was. From my own research, going back a little while, on the Spectrum, for example, there are only about 10 games ever published that leveraged the network, the Interface 1 network for those games. Things like Full Throttle, I think it was, or no, TT Racer. On the QL, there were probably about 5 or 10 games, again. Very few used the network, and it's a real shame because it would have opened up a great deal of other possibilities. The other thing about the Sinclair network, as well as it physically requiring very few components, very cheap and easy to find, also it places very little demand on the processors that those computers use. If you're running a Spectrum, for example, a ZX Spectrum at 3.5 megahertz, you're not going to be able to run a full TCP stack, if that means anything to you, on such a machine. You're not going to be able to run SSL connections, for example. Any of that requires much more modern hardware. So whatever we use for the network has to be pretty simple, as I say, reliable, fast enough for our retro purposes, but it doesn't have to be anything like what we're used to in normal networking today. So what sort of features does a Sinclair network offer us? Well, I'll differentiate a little bit here because the Spectrum and the QL are both compatible in this regard. From the outset, there were some issues timing-wise, but otherwise they were physically and software compatible in a peer-to-peer network. In a peer-to-peer network, here I'm talking about the ability to say at one end, on one node, the ability to say, I want to save this to another node. On the other node, on the other computer, you'd have to type in a reciprocal command to say, I want to load it. So you need to actually access both machines at the same time. Both the QL and the Spectrum support that out of the box. The QL, however, in its later revisions, also supported a true client-server approach with many features that we're actually used to with the Microsoft networking that we use and many of the other more modern networks that we use today on our PCs. I'm going to go a little bit technical for a moment. What does it actually look like on the wire? It's very simple. I mentioned that it uses one cable with really just one core in it, so it's a one-wire network with ground and the actual signal wire. And during the time, it uses technology that actually transfers well to Ethernet, so it uses multiple access, collision detection, carrier sense in very similar ways. On the screen at the moment, what you see is over a period of time, those black blobs represent wherever there is a packet. And intervening each of those packets, there's a gap. Now, you might say, well, that's not very efficient. But this does mean it can share the actual transport layer, the actual wire, the time on the wire for multiple machines to work and to slip in the gap to get their own packet in. If we were to break down one of those darker blobs that we see there of the actual packet data, here's a little bit, there's a wire trace. And here we see that it's broken up into certain segments. So the first thing you have to do when you're sharing a wire link like this, a single wire link, is you have to check to see if somebody's already on it. In other words, you have to see if somebody's claimed the network. And for this, we use a scout. First of all, we listen for a quiet time. Then, just like in a conversation, we hear a gap, and then we'll actually place a positive signal on the wire. And then we listen during that time to see if that signal has been corrupted because somebody else is trying to do the same. So this is where the collision detection comes in that we're familiar with more with other more modern networking. Once the machine is determined as it's sending that it can now claim the line, claim the link, it then sends immediately the header. Very simple, 8 bytes of data, all in a serial format. The Sinclair network, like many of its kind, is an asynchronous one with a start bit, 8 bits, and then a number of stop bits, very much like an RS-232 serial connection. The one thing that differentiates the Sinclair network from even things like a full TCP or UDP that we're used to on PC networks today is the fact that we actually do have a very short latency that otherwise, but still we're able to check whether or not that packet or that header has been received successfully. This is quite important in terms of the reliability of the network. And that's sent immediately. Again, a little bit more technical, but if you want to have that kind of checking to know whether or not the message you've sent down the network has been received by the intended recipient, you normally rely on a full handshaking in TCP, on the TCP stack and in IP network. But that introduces a great deal of latency when you're trying to send packets. This one is very efficient. Literally within the space of about 200 microseconds, you know if the recipient actually got your message. So the header is sent, we claim the line, the header is sent. In that header, just as you find in any other network, we say who we want to speak to, who we are, and these are 8-bit network numbers, so we can have up to potentially 255 different nodes on a network. Although it's limited in software to just 64, that's not such an issue really. We also say what sort of packet we're sending, how big it is. It's just a simple bit of information. If the recipient was listening at the time and it was actually addressed to them, then it will send that acknowledgement back. Once that acknowledgement is sent back, we immediately then go straight into sending the data packet. And on the Sinclair network, typically that's up to 255 bytes of quite small packets, which again allows the line to be released ready for other machines to join in and actually claim the line for themselves, so sharing the available bandwidth of the simple line. In terms of speed here, if you were to see on that network trace, all the positive edges there, basically we're talking about a bit rate of about 90 kilobits per second. Nothing massive, but when you think back in the day, the best we were doing with, say, a serial connection was perhaps, I don't know, 19,000 bits per second. To get up to 90 is actually quite significant, especially for our short files that we want to transfer. In fact, what I have proven over developing the network, on the Sinclair network over the past few years, is with the right hardware, we can push that, still using the very same cheap cabling, we can push that up to about 8 times the capacity. So, for example, I have a setup over there, it's not working at the moment, as for other reasons, but where we can actually send at about 750 kilobits per second, which is approaching what you got with the fast EcoNet, for example, all on one single wire. Now again, you compare that to, say, an EcoNet cable and an EcoNet system like on a BBC. It was called EcoNet at the time because it was supposed to be economical, and it was compared to what else was around at the time. But the cabling and the actual hardware you need in the BBCs and then the later Acorn machines was actually quite laborious and quite costly. So again, cheap and simple and still fairly rapid, with the possibility to go faster with the right software enhancements. Okay, so why didn't it really take off? Well, there were a number of problems that people found, and I discovered and have managed to address by developing new software operating system drivers, both on the QL and the Spectrum, to overcome them. But such things as, and I have to read my screen, excuse me. You can read them up here. The hardware itself was unreliable. There were various QL versions, for example, where the motherboard didn't allow for very tight timing. And this is all being, what we call, bit-banged. So it's, the CPU is responsible for actually setting and resetting the line asynchronously. Timing problems between different machines. And if any of you have played with Spectrums for a while, you know that as they warm up, they actually get faster. So that can actually affect the timing because, again, the CPU is bit-banging each bit. So you can get timing mismatches. I mentioned here stuck net ports. Well, these simple jack sockets, not physically stuck, but rather the line drivers can end up being stuck at 5 volts, bringing the whole network down. Simply changing a transistor in the circuit usually works for that. And because we don't often use those sockets on our Spectrums and our QLs, typically they rust. So replacing the socket can also help here. There are a number of other more sort of user-related issues that tended to cause problems, but the gist is that what could have been a very effective and was intended by Sinclair to be a universal networking standard never really took off. I think we can now, with more modern technology and understanding what those problems are, we can begin to bring it back and start to use it, and not just on Sinclair machines, and I'll come on to that point later. So what next? Well, as I mentioned before, it's quite possible to improve the speed of the network. We can improve its reliability in a number of ways. For example, another common complaint with the Sinclair network is it uses a very simple, what we call a checksum, to determine whether or not the recipient has actually received the data that was intended to be sent. Modern networking uses what we call CRC checks, etc., which are rather tedious to compute. They require quite a lot of compute power to do it. We don't want to go that far, but there are ways to use a different kind of checksumming to make that more reliable. Something that I think would be very interesting is to see more multiplayer games developed. If we can get cheap networking available across more of our retro machines, the possibility then, if you like, the incentive for the games developers, and we have a lot of them today on the retro scene, to actually start designing their games for multiplayer. Classic games that are more sort of turn-based are obvious candidates for that, but needn't be. We can have RPGs, we can have arcade games. As long as these packets are short and you know how long they take, you can actually factor that in to your gameplay as a designer and actually start to actually have multiple games on there. And then what interests me most here, and again, I look around the room, obviously Sinclair only represents probably 5–10% of the machines you see here. But the simplicity of the design, the cheapness of the hardware, and the fact that we already have example code for both Z80-based computers, so that covers probably about 50–60% of the machines here, and 68,000-based computers like the QL, but that cover probably another 40% of the machines you see here. We've already got code for that. The ability to turn that into code, porting it over to whether it's an Atari ST, an Amiga, whether it's to other 8-bit machines like the Enterprise Elan or Enterprise 64, or the Sam Coupe, or any number of other machines, is feasible. Those machines don't need to be very powerful because the network protocol itself is so simple and so cheap. This is what I'd like to see. As I say, if you come back here next year, I'd like to think that at least another 2, 3, or 4 different machine types are connected in a network, such that you don't need then to have those expensive hard drives, CF cards, SD cards, etc., all loaded up on each machine, which takes us hours to set up here, as I'm sure you're aware, but have them all pulled down in real time as the user selects files to play. That's what my vision for what we might see here next year. So with that, if you've got any questions, I'd happily take them. I've probably quite a bit of time left over. Mark, what is the timing? Okay, 5 minutes, that's not so bad. If you don't have any questions, I've got some for you. Oh, please go ahead. We'll give you a mic.
Okay, so where do we go to learn more?
Good question. So you've got a couple of ways there. You could email me. I've managed to find a free Gmail address that hopefully wouldn't upset anybody over in Sky Broadcasting, who own the Sinclair copyright now. Otherwise, you'll see there's a lot of chatter I'm usually part of those conversations on various forums, whether that's on the QL side, the Spectrum side, and elsewhere. For example, on the Spectrum Compute Forum recently, the developers of the Fuse emulator were looking to see how they might be able to actually network multiple instances of the Fuse emulator, which is for the Spectrum, on a PC together, and then maybe even to be able to link them to physical Spectrums as well, opening up the possibility of moving all your files around again, even from an emulator to real hardware. So a number of these forums up on screen, you'll find quite a lot of chatter about networking, and I'm usually putting my oar in there as well. Thank you for the question. Please, yes. Oh, you want to wait for the mic?
So you mentioned the Next. How would we connect the Next? How would we connect the Next?
Right, so the Next, indeed. So at the moment, the Next running the QL core does support the network. I was going to show, in fact. You need a little bit of extra hardware. On the Spectrum Next, for example, there's very little exposed ports available. So it just so happens that the joystick port has the capability of not just reading information, but can also has one bit available, and that's all we need in the Sinclair network, has one bit available that when it's enabled, which the latest QL core by our friend Leon over in Greece, brilliant bit of a brilliant core for the Spectrum Next. He was able to, I worked with him to enable this. We, with a little bit of very simple discrete components in here, there's a couple of transistors, a couple of capacitors, about 4 or 5 resistors, and the design is online, and you'll probably find it on some of those links that are shown on screen. I'm looking to see how we can sort of make this, productize this. It's quite a neat one. So it plugs into the joystick, and you can still plug in a simple Atari-style joystick into an extension cable, so you're not losing anything that way. Now that's at the moment that's only available when you're running the Next with the QL core. That's just because we haven't gotten around yet to porting that driver, which I developed back in November, wasn't it? Yeah. And bring it actually into a native Next environment. He can fix it for us. Okay. Brilliant. That would be very helpful. Well, I'm not going to talk about Spectrum Next because that's coming next. I'm very excited about that talk, which is probably why most of you are actually sat here. I know that. But no, so the Spectrum Next will have full networking. And just to point out, a real issue for instance, when you use the QL core, in fact, most of the other cores on these machines, is they can't natively access the SD card that you can on the Next itself. The moment you load these cores, somehow we typically use container files of some kind. They could be SCL disk image files, TRD disk image files. On the QL, we use these Win QLX files. How do you get them into those container files to run? So it's a bit of a chicken and egg problem. If you can actually network in, and within the actual core, once the core is running and is able to access those files within the container file, then of course you can pull them straight from another machine. On that particular point, I didn't mention, and I should have done really, PCs running the various QL emulators can also connect natively to the QL network or Sinclair network. The club adapter is another little invention by yours truly. Again, all open source. This one uses a microcontroller, effectively rewritten in C, the network protocol, and then communicates with a USB connection into your laptop. So again, this was actually what started my journey down the Sinclair network, was because for my son Alessandro, who's in the audience here next to his beautiful mum, Amanda, I decided I wanted to build on the QL, I wanted to connect to his Scalextric system. Okay? I don't know if any of you even remember Scalextric. Looking around, maybe some of you are a bit young, but yeah. Thank you. I was coding on the PC, developing the software there, and then using chunky serial cables, which didn't always work, to transfer each new iteration of the code to the QL, which was then connected with some electronics to his Scalextric. And it was tedious, to say the least. Even with an SD card, it became tedious. You have to copy it, take it, put it back in, read it off again. So that really was what sent me down, well, there must be an easier way. That's when I remembered they had network ports on them, and that's why I decided I needed to be able to connect my laptop to it as well. Thank you for the question. I think that draws us to a close. You can now wake up because the next show is going to be slightly more entertaining, and I'm very much looking forward to it. So thank you very much for your attention, and if you have any further questions, come and find me over at my non-working desk. Thank you very much. Have a great afternoon.
Martyn, thank you very much indeed for that. That was really absolutely fascinating. Appreciate it. So we're going to carry on the Spectrum hardware conversation, as well as the Spectrum software.